she used an example. I think he's converting into binary zeros and one. If I'm not really sure.
Okay.
But she used an example when she was talking about it, and in that
Okay.
example, I was able to see that there repeated twice, and that's why we had one in different places.
Yeah, thank you. Okay, one auth encoding is really about okay, if you have a distribution of if you have a okay, let's say if you have data now and you majorly use it in structure tabular data sets, structured data sets. So if you're using if let's say in a particular column now, let's say you have students, okay, let's say you have different professions. Do you get? So you have different professions. You have students. You have teacher. You have okay, okay. Instead, let me rather than this, let me just like let me go to the this particular slide. Okay. So basically, looking at this now. Say that okay, the quick brown fox jumps over the lazy dog. One hot encoding is a method of okay, it maps. It's just say that okay, in this particular column now, okay, this particular column of the mhm, this particular column of D, um, in this particular column of D, is this present? This particular column is these are the labels, right? So in this particular column, is D present there? So yes, is D present here? No, is D present here? So where that particular where that particular what I call it now, um where that particular job, let's just let that particular text is present. So you mark it one. It's just like absent and present. Is it present? If it is present, you give it one. If it's absent, you give it a no. So this thing that we can even have like combined. You can just like remove this particular column, right? So looking at it, you can just remove this particular concept. Okay, at this particular point where we have the instead of one here, okay, there is one here. Instead of writing another one, I just like okay, probably for the position, I just like, okay, put one here. Well, I don't know. There's a little issue here. But regardless, I hope you understand the major reason why we have this. So when we are doing this particular bonus encoding, it helps us to expand our data set. So even let's say the quick brown flow, this stuff now is just in one column. So when you use one-hot encoding, you expand the column by the number of unique characters in that column. Do we get what I explained? Do we get what I explained just now? If you don't, please feel free to talk. You are not responding. Well,
Sorry, sorry, not exactly. Please, could you go right again? Sorry.
okay. Okay, let's say the quick brown fox jumps over the lazy dog. If this is in a particular, okay, let me use an example of, okay, let me, let me go to the notebook now. Let me go to the, okay, okay, I'll still, okay. Can you see the notebook?
Yes, yes, I can.
Okay. Let's say in a particular column, let's say you have profession. So okay, let's say let's say data sets. This is just an imaginary data set now. Say data sets like a column in data set now which is called profession, is is what is um okay. Let's say we have students, we have teacher, and we have students, we have teacher, and we have let's say engineer. Okay. So let's say these are the unique characters in this particular column. Do you get? So when we want to do one hot encoding, this is in a single column. Hmm? So okay, look at come back. Let's say this particular the quick brown fox jumps over a lazy dog. It is a single it is a single text. It's a single sentence. It's a simple sentence, but no, I think this thing will be better if I show if I which data sets can I grab right now? Oh, let me just say this. This is one of the look at this D now. It is just it's having 1 and 0 0. It means that as wherever it is present, it is one. Where other places where it is absent, it is zero. But there's also something called label encoding. Then
Yomfe, should we take it slow? So let's go back to your example of student, teacher, and engineer. And um, who said it was not clear? Precious. Let's take it. Was it Precious?
I think it was precious.
I think it was Cecilia, but I
Okay.
also need the explanation.
Okay, so let's stick with this example. Let's say that in a column, remember we did rows and column tables when we were talking about database, and in that column called profession, as Yomife was explaining, we have three categories. We have student, teacher, and engineer. But because these are text, we need a way to represent them as numbers. And it becomes very tricky. Like if it was just numerical data, we could get away with it. But in much more complex setting, we may want to do things like normalization. But right now, let's stick with categories. How can we represent this in numbers? So Yomife was explaining that one of the ways we can do that is by doing something called one hot encoding. And literally what one hot encoding does is that first it will look at the unique values in that column. In this example, how many unique values do we have?
3.
Amazing. And so we know that we have only three unique values. I mean, but we can have more. It could be student, 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 teacher, teacher, engineer, engineer, and doctor. Then how many unique value would that be?
Then, if I counted properly,
Okay, we will count again. So Yomife, help me with that example. Yes. So we have student, 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 teacher, teacher, engineer, doctor.
4. I don't think we'll consider the repetition.
Amazing, Precious. You're speaking the language now. So, Yomife, just in case people are watching this later on, all of this should be string. This code would not run the way we've written it like this. But this is an example. So we in this example where we've included doctor, we have four unique
Ẹni tó
values.
ní ànímọ̀ kó tó máa ṣe kínní lọ paranoia kẹ́sọ́ pé ní
So we have four unique values. So what one hot encoder would do is that it's going to take these four categories, and we will create 4 columns. 4 columns of those unique values. The first one will be student, the other one will be teacher, then we would have engineer, and we have doctor. And in each of the row, whenever we see a student, if for that row it is a student, then we will put 1 under the student category, and the rest of the category would have what?
0.
Exactly. Because in all those 4 columns, they need to sum up to 1. It can only take up one value. So we will go to the second row. Let's say in this in our example, the second row has teacher. I know the way we've represented it now, it looks like a list, but think of it as a column. Like they are all like you have teacher, then in the next row, yes, exactly. Thanks, Remife. So we have that. So it's a row. So in the second row, you have teacher. So then in the remember our columns now. We have student, teacher, doctor, engineer. That is the way we are formatting the columns. So in the second row, what would student column be?
1.
You think
0, sorry. 0, 0.
amazing,
Sorry.
precious, amazing. So it will be 0. Then what would be teacher column value take?
1.
Exactly. And the engineer will take
1.
engineer will take 1 in the second row.
0.
0,
Is it
exactly.
0? Oh, that's the first time.
Exactly.
Okay.
So yeah, so let's Yomife, let's that that's we sh let's try to make this work in the way we are talking about the example. So yeah, amazing. I like that the code suggestion is already having that. So let's do students, teacher, right? Yeah. Just let the auto complete it the way it was trying to help before. Teacher, um, engineer, doctor. Yeah. And so we said that for the first row, a student will take up 1 because student is in the first one, right? So it will be 1, 0, 0. And in the second row, it will be 0, 1, 0, 0, right?
Okay, like I think I think we should let them
Yeah, so
fill
no,
the
because we've done the first and second one. So the third one, someone should tell
uh,
us what it
so
should be.
now okay. So now for the teacher aspects, what would be
I think
what
we
will be
just
my
we just did that one. We said it's
okay,
zero
okay,
one
okay.
0, 1, 0, 0. So let's do the third one. So what's the third one, guys?
0010.
Amazing.
0.
0, 0, 1, 0.
Zero.
How about the fourth one?
0001.
0, 0, 0, 1.
Do you think so? I'll let you think again.
1, 2, 3, 4. This is not the fourth one. What will be the first one?
The first one is
Okay,
the
that will be
student.
0, 1,
The teacher
0,
should
0.
Zero.
have 1.
So so this is number. This
Yamife,
is 1, 2, 3, 4.
can you please
Okay.
help
Okay,
to make
that's
sure
teacher.
that the student is also small letter, so that everything is unique.
Oh yeah.
Yeah. Okay. Yeah. Okay.
Those
So
one.
let's do it again, guys. Let's count. So we are
Okay.
on the fourth
So
one. Like
1,
let's
2,
count
3, 4.
one, two,
Yeah.
three, four. 1, 2, 3. So what should
So
the fourth one be?
what should be
0100.
1, 0.
Amazing.
is
Okay.
everybody agreeing with that? Okay.
How about the fifth one?
0.
Feet 1. 1, 0, 0, 0.
Yeah. And the sixth one?
0, 0,
0001.
0,
Okay. And the seventh one?
1. 0, 0, 1.
0010.
Amazing. So, guys, is there someone that does not understand what we have done? It's okay. We can go over it again. I will ask Precious and Cecilia to be the teacher this time around. So, if you don't understand, I want you to speak up because one hot
Yeah,
encoding. Onome,
from the yes, from the fourth. Sorry.
Oh no, man, please. I think you have a little bit of feedback. You can speak, but I think you have a bit of feedback from your side.
Okay. Okay. So from the fourth one, how come? Because I was actually expecting 0001, but now I'm seeing zero
okay.
one.
For the fourth
Onome,
one, okay.
the fourth one. Onome, let's count it together. So, 1, 2, 3, 4. What is the fourth one in our data? The fourth row. What does it have?
Okay, doctor. Okay.
No, the fourth one. The fourth
No,
one is not doctor. Let's count now. We are counting with starting
Okay,
with
teacher.
what's the
one.
okay?
We are using one to count. I know that in Python sometimes we start with zero, but this time around we are counting from one. One,
Um,
two, three, four. Is teacher, right?
Yes.
Okay, so what should the thing be? Let's look at the results. What do you think now?
Okay, so we have to copy the one we already had for teacher previously.
No, you just have to let's think about it together. Who should get the one? You know, we said it's one auth encoding. Somebody has to have one. And the person that will get one is the person we are currently on right now. So teacher is number 4. So teacher will have to
Yes.
get one in that column. The rest of the people get 0.
Okay.
Does that make sense?
No.
Onome,
Yeah.
you said it does not make sense, right?
Yeah. The only thing I can get is that maybe because we've already done teacher before, as it was teacher was number 2 before.
Yeah.
So we can as well use we gave it one, so we can give it one again.
No, yeah, you're correct that it gets the same thing, but I want you to understand why that is, and that's what we're trying to explain here. Like in one hot encoding, the first thing that happens is that when you have a column, this time around we started with a column called profession. Do you understand?
Yes.
And the profession column has 1, 2, 3, 4, 5, 6, 7 rows. Does that make sense so far?
Yes, it does.
And so now we want to create a representation based on these categories. And what we will first start to do is that we will look how many unique values do we have in this column. And we found out that we have 4, right?
Yeah, that's true. Four.
Okay, so we see that we only have like a student, teacher, engineer, doctor. The rest are repeating themselves. It does not matter right now because we're trying to create a representation. So in order for us to do this one hot encoding, the way it works is that when you look at the first row, which is student in the professions column, we will say that okay, because it's student, the column that gets 1 would be student. The rest will get 0 because each row has to sum up to 1 eventually. This is why it's called one hot. Are you following so far?
Yes, I am. Yeah.
So because when we now got to teacher, we put 1 in that row, and you're correct that in number 1, 2, 3, 4, in number 4, and we go back to teacher again, it is the same as number 2 because it's repeated. So teacher still get 1.
Okay.
So this is how like one hot encoding work. So I would let's add an extra row. Let's say we have maybe another student in the last one. So what would the last row be now, Onome?
1000.
Exactly. So this is how we will continue to do. And imagine that we now have another category that shows up in our data. Let's say we had another profession like vibe coding or something like that. Then our column, how many unique values would we now have?
Fine.
5. And what now happens? So like in the last column, what would be the representation?
0001.
Exactly. So we need to add an extra column after doctor to say now we have vibe coding. We extend our column to include vibe coding, and we add 0 to all of the other columns that are not vibe coding because they already have a number. So and the last row would be 00 0 0 0 0 0 0 0 1. And that's exactly, and right now, from just talking, we have just implemented one hot encoding.
Thank you.
You're very welcome.
So, okay, thank you so much for that. So is there anybody else still has any question regarding this? Does anybody else still has? Is anybody is it still is it in any way still unclear to anybody? Oh, everyone is clear.
Ladies, at that
Okay.
age now, wait.
How night they did loud. You know how many men where they cry?
Okay, so okay, let me let me proceed. So that is also this essentially is what one of encoding does. So what I was trying to explain earlier, this is just a singular color in our data set, right? This is the title of our this is the title, and this is just a particular color in our data set. So from just one color, we have expanded our column from 1 to like how many now?
5.
5. So do you get that? So depending, you do this based on the number. So your data set will increase, your column will increase based on the number of unique values. So if you so depending on and you will do this for all categorical column in your data set. So this is just for profession. Let's say if you have which other profession, which other column categorical column can we have in our data set? Probably residence, maybe like where you live, and then so if you are sorry, so you can if it is residence now, so you do this. Let's say residence now. Okay, you are from Nigeria, you are from Cameroon, you are from Sierra Leone. You also do this same thing for it. Exactly. So we majorly do this whenever we are implementing machine learning algorithm. So there's an alternative to this one-hot encoding. We'll call that one labeled encoding. There's also something we call labeled encoding. It was not, I'm not, it was not explained in the what's it called? In the tutorial, but just like because it is still possible you use it, and if you come across it so that you won't be lost and wondering why is this. So the different label encoding is also what we use to represent data in before we pass them into a machine learning algorithm. What it does is that so instead of look at the way one of encode does it now. It just like here it just marks present and absent for each row. So instead of that, one of encode label encode also it still retains the color, but what it just do is that it gives each of these unique variables, it assigns them a number. So okay, student is 0, teacher is 1, engineer is 2, doctor is 3, vibe coding is 4. Do we get that? So if it says okay, let's say if it says students, okay. Let me come up here. Okay, let me see. Okay. Students is 0. Teacher is 1. Are we following, please? Engineer is 2. Doctor 3. 5 is 4. Okay.
Let me share. Can you please make a dictionary variable? So
Okay. I think let me do that. Okay, let's say okay, label. Okay, let me just okay, so students is what? 1. Students is what? 0. Sorry? Teacher 1. Engineer engineer is 2. Then that's 3. And by coding 4. Do we get this? So now we cannot see. So let's just okay. Okay. So now that we have this, we have students and such. So based on based on this mapping that we have done here in our what's it called? In our dictionary. So what would be the first one here? What would be the first row? Are we there?
Yes, we are there. Are you asking what should be our first value?
Exactly. What would be the first value?
That if we are starting with students, then that should be 0.
0. So, sorry. 0. Okay. Oh, what would be the second one?
1.
Okay. What would be the third one?
That should be 2.
Okay. Is it only Ghanaian that is on the call? Someone else should kindly assist Ghanaians. So what will be the next one? So we have what will be the next one? We have done students, teachers, students. What will be the next one? Do you understand what you are doing?
3.
1.
Is it not doctor?
1, 2. The next one is teacher.
The next one is teacher. Then it's 1.
We've done 1, 2, 3, 4. We've done 1, 2, 3. So we are teacher right now. We are here at the moment.
1.
1. Good. 1. So after teacher, what's next?
0.
0,
3,
3,
3. 1,
2,
2, 3, 4, 5. 1, 2, 3, 4, 5. We are numbers. We are the sixth one, right? That's doctor. So what is doctor? Okay,
3.
doctor is 3. This is 3. Okay, so after doctor, what's next? Engineer. So so what are we going
2.
to
2.
write? 2. Good. And afterwards,
0. Student.
students, that is 0. And the last one will be what?
4.
4.
4. So these two are the ways in which we represent our categorical column and text in in during machine learning algorithms. So the only reason, the difference between this label encoding and this one-hot encoding is, you see, looking at this one-hot encoding now, you see that it just gives you, okay, present, absence, present, absence, present, absence. But this one is giving you 0, 1, 2, 3, 4. The numbers are looking like it is looking like it's increasing or decreasing. So it's kind of introduced a kind of relationship between the data. Hmm? So it can introduce a kind of, I'm coming, can you hear that I'm coming? It can introduce to say that, okay, teacher is more significant than students, or engineer is more significant than teacher, doctor is more significant than engineer, and code is more significant than doctor. So, and which we do not want, or else you are saying, okay, let's say this particular column is like let's say good, bad, ugly. I mean, do you get bad, worst, better, best? Do you get? So there's a kind in that part. Even though you can use one of them coding, there's also a kind of degree, like interrelationship between it. So you can use that. You can use label encoding there. But if it is just like something like professional, there's no like one does like there's no like in relationship. There's no kind of degree of importance that's big them together. So one of encoding is fine. So Ghanaians, what did you want to say?
Yes, I wanted to ask that when is it best to use one of encoding and label encoding, right? But it seems you already mentioned that the label encoding has to do with more of hierarchy, if I'm right, if I get
Exactly.
you right.
Yeah,
I
exactly.
think that's what I just. So my question, another question I have is, okay, now we are only like having a sample testing with just a single column, right? So what if in a situation
Mhm.
where we have a very large data set that has like so many columns? So are we
Mhm.
supposed to? Is there a better way to do this that we don't have to be doing it manually this way?
Yeah. Oh, of course, we don't do it. We don't do this manually. We don't do this manually at all. There are library. There are there's the don't worry. When we start the week, you'll be introduced to the machine learning library, scikit-learn. You'll be introduced to it and you see. So from the library, you use one of the encoding. You can use label encoding. So we won't be doing this manually. But if you are going to be doing it, you need to understand what exactly is going on, so that you probably in the process of building your machine learning model, okay, what is wrong, what exactly do I want to do. Nobody is doing this manually. You don't get any prize for doing this manually, but we are doing this manually so that you understand how the library works, how when you are calling label encoding, when you call the label encode function, you know exactly what is going on. And when you call the one-hot encode function, you know what is going on and you know what to expect. So when you know what is going on and you know what to expect, if something is wrong, then you know where to like debug. Is that clear? So definitely in practice, we won't be doing this at all. nobody does this in real life. But this is just a way to explain it and ensure we understand it. So this is label encode, and this is one-hot encode. If you feel like there's an hierarchy or an interrelationship between your data, then you can use label encode. But if there's no hierarchy, and if there's no hierarchy, just stick with this one-hot encode. If you are not sure of what to do, I think you should just stick with one-hot encode. But once and if you care about the interrelationship and the degree and the hierarchy within your data sets, you can you can um you can use the benefit. But if you don't care about the relationship while building your model, then one of them code is the way to. So is that clear? Any question before we move ahead? Any question before we move ahead? So the person that asked about one us encode on the group, I don't know if he's on the channel. I don't know if he's on the call right now. Okay. So okay, let us do this. Oh, this is bag of words. Does anybody understand the concept of bag of words? Okay, are the encoding generated manually? Okay, I think I've answered that already. They are not generated manually. Like we don't do it manually the way it is. We use the library to do it. So and when you are doing label encode when you are doing label encoding now, to be sure that the relationship, the hierarchy that is in your data set is preserved. So you can actually you can specify how you want it. Like the way we did, like the way I said, okay, this is student is 0, teacher is 1, engineer is 2. So you can specify because um um the library might mix things up. So it can instead of okay, let's say you have let's say there's a column which has grade A to E. So definitely there's an hierarchy and there's a relationship there. So to in order to be sure so in order to be sure that okay, grade A to grade E is preserved, you might specifically say that okay, this is how I want it. Or and then probably after, or you can say that okay, can check it after you perform the belly encode, you can now check how it's encoded this. So Teja has dropped a nice library, a nice the what's it called? She has dropped the documentation, so you can read up on it and see how it works. So is that clear by everyone? So okay. Now, bag of words. Does anybody understand the concept of bag of words? Does anybody understand the concept of bag of words?
Hello, Yamife. Can I try?
Yeah, for sure.
From what I see, looks like the length of each word is being counted and then um, used in the encoding itself.
Is that it? Okay,
The
thanks for the
frequency,
try.
the,
Sorry?
the frequency of the occurrence of the words.
Okay. Anybody else wants to give it a shot? Anybody else wants to give it a shot? Okay, let me just explain the concepts. So bag when we talk about bag of it's just like okay, you put all okay, let me go back to the example I gave now. So it's just you put all the words down, you put everything into a bag. So it's just like okay, look at each word now. How many, okay, in this sentence now, how many times do we have the?
But Elijah, was it Elijah that said frequency of the word being counted?
I think it was
I think you
Precious.
said it not.
Because the person would be correct, right? Because
Yeah.
there you count how many times each of the word occur, which
Okay.
is exactly
Oh,
what is.
oh, sorry. I thought the oh, what I thought you said was like the number of like letters.
No, it said
Sorry for
frequency
the
of the
miss.
word.
Okay.
Yeah,
Oh, sorry, I didn't get that
so
part. Sorry.
they're correct.
Yeah, correct. Apologies, Precious. Sorry, I think I didn't get that part very well. Okay, so so this all this was now. It's just like in a bag of words. It just I said it's just like in a bag. It puts everything just as it says, bag of words. So it puts all these words, it puts everything into a bag, and then it counts the frequency of each unique word. So now the this word, it comes up how many times? What's the frequency?
2.
So exactly. So we have it twice. Then so you just like put it inside the bag, inside this bag, and said, okay, in this bag, if I am picking a word, what is the probability? So what is the chances of me picking D,
Yeah.
which
I don't
is
like this image. It's very confusing. If you
very
look at the bag,
confusing.
you can see that D occurs like 3 times, and one is
Oh,
capitalized, and one is. But
so
it's.
yeah.
But we should look at the sentence itself.
Okay.
Yeah,
Exactly. Let's just look at this.
and just think
So,
about the fact that we're not considering the case, because then if you're considering the case, the capitalized one would be a different word from the lowercase one. But usually
yeah.
you lower everything, you turn everything into one case, and then you count the frequency of unique words.
Yeah. So, yeah. That's it. That's basically what a bag of words does. But the only challenge is that the only challenge is the more words, if you are working with okay, let's see how we are using the constitution now. If you are using bag of words, so that means it will give us a it will give us it will give every of those words, it will give them it will give them a particular probability. And the thing is how would I call it? In big models and in all these models, it is not efficient. Why? It doesn't tell us, okay, this word is at the beginning, this word is at the, it doesn't talk about the interrelationship between what. See, like when you dump everything inside the bag, even though pardon the representation of the image, but you can see that you see this D is beside the jump. It's beside force. It's beside everything. It is not precise. It didn't precise that okay, this is the beginning, and it's not telling us okay. If you put everything in, you don't know if it's the dog that jump over the fox or the fox that jump over the dog. Is is the fox brown or is the dog brown? It doesn't all these quantifiers, it didn't all these qualifiers, rather, all these adjectives, it didn't like explain us, it didn't explain it's not like going to like retain those information. So that is one of the reasons why we don't like use it in these days. But we before we got here, we do use it. So I guess, is that clear? Do you understand the concept of bag of word? Do you understand that we should go over it again? Ah, I'm not hearing anybody.
I understand about others.
I deal with you, my Oga. Thank you, sir.
Okay. So another thing is that in this bag of words now, if there are words that are okay, let's say synonyms now. Okay. Can anybody give me two words that are synonyms to each other? Any synonyms? Um, clean and
Fast
tidy.
and quick. Fast and quick.
Exactly. Thank you. Okay. So fast and quick. So you know, as we are speaking to each other now, we know that okay, fast and quick, they are synonyms. But this one it doesn't understand that. It will see quick as a different character, a different word, fast as a different word. So these are one of the shortcomings. And the more your text, the more your the more your the, I mean the more your text, the more your vocabulary size. So it keeps increasing and increasing. And actually, it's also computational stuff. Yeah, love and adore, same thing. So even though, so it will separate them. So those are we'll still come. So we'll see how other models, how those was tackle this particular issue. Yeah. So now the next one. So I hope everybody is clear on the bag of words. I hope everybody's clear on the bag of word before.
Yes.
Okay. So, so this the next one we'll be talking about is n-gram. Does anybody wants to shoot their shot and see how and explain n-gram to us? It's basically already on the screen. So if anybody cares, okay, let me proceed. Okay, proceed. Oladile, right? Yeah, please proceed. Oladile, are you speaking? I'm not hearing. I'm not sure I'm hearing. Okay, let me proceed. Okay, n-gram is just like a is a way like models like estimate the next one. As I don't know if we've said this here. I think we said this in the one. These language models, they are not working magic. They give us the next word based on the probabilities. Mm. So they predict the next word based on probabilities. And so one thing n-gram does is that to compute the probability of the next word, it considers a few words that has been given before. So which we will call like context. Mm? So the n-gram, if you say this 1 gram, the only context it is considering is what? Is one. It's only considering a single context, which is the last word. You can also it's only saying okay, it's the only okay, this is our sentence. Welcome to AI Saturday Lagos. The only if to predict the next word, okay, this is our first word now. Welcome. So predict the next word too. Is only considering welcome. And then after it uses welcome to predict two. Then after gets it uses to predict AI. Then after using AI, then it uses it to predict Saturday, and then it only uses Saturday to predict Lagos. Does that make any sense at all?
Yes, it does.
But if you are saying 2 gram, it's only considering the last two words to predict the next word. So if it's saying welcome to, the first two words are welcome to. So when it uses welcome to, it uses those two to predict the next word, which is what? AI. So then after predicting AI, then it now picks to AI to predict what? Saturday. Then it now picks AI Saturday to predict what? Lagos. Is that so? Same thing with the trigram, the trigram. But the only thing is that if you're only considering a single word, it's two word or three words, there won't be coherence in our text. Do you get that? There won't be coherence. If I'm okay, let's say welcome. There will be if I say welcome, there will be a lot of words that our model can pick from. So and it might not even it can say welcome here. Okay, you can say that welcome. If I say and if it eventually tells me welcome to, you can say welcome to this place. Welcome to my humble abode. Welcome. There's a lot of or it might not even say, it might not even tell you that welcome to my own world. It might take me different places. That's because it is only considering just a single word. So the coherence will be lost. There's no context. It won't be able to like follow through a thought process. There won't be any context because it doesn't have enough information to predict the next word. So even this triangle. Okay, let's look at this diagram. Welcome to when it gets to this particular Saturday Lagos and it wants to proceed, it has already forgotten about welcome to AI. It has totally forgotten everything. The next word it will be predicting might not even have anything to do with AI or not even have anything to welcome. So the stuff will just be very random. Not like very like it won't be coherent to just be all over the place because there's no context it is following. Does that make any sense at all? Or should I come again? Does that make any sense? Are we all clear on that? Okay. All right. Thank you. So the next one we'll be considering is just like TF, IDF, term frequency and inverse document frequency.
Oh,
It uses this kind of
wait, before we even do that, let's go back to n-gram. So now we know that we are using, for 1 gram, we used the word before to predict the next one. But the question is that how do you estimate the probability? So you have a bag of word, right? You have like the entire internet. You're trying to find a probability estimate. Like what's the frequency of welcome given two, or like two given welcome the other way around. And in order for you to get to the closest estimate, you need lot and lot and lot of data. So if you decided to estimate 1 gram, maybe you can have a lot of a lot of welcome to AI Saturdays, maybe not. But as Yomi first said, you might not really get a very coherent sentence. So you now decide that, okay, let's do like probability estimation of the bigrams. Um, how many times do you see AI come before, like when you have welcome to, then the next word that come is AI. Then you do that probability estimate as well across all of your corpus, which is your database. And then next time when you're trying to do like generated text or like do some prediction, you can use that estimate to predict that once you have these two words, you would always have AI. The reason why I'm mentioning this is because once you go deeper into understanding n-gram models, you understand that it's about getting a very accurate probabilistic model, and it has its own very like it was used for a long time, and you can get just as far until it breaks down. So once you start to estimate bigger grams, like 3 or 4 grams, you start getting into this point where you don't have enough probability mass on those estimation, and so you have to think about different techniques and so on. And so I just want to mention that because when you start reading about it, you start to see that there's more to it than this explanation that we have right now. It's to not overwhelm you, just to help you get the basic gist of the grams, but for sure this you need to study this a bit more. And if you have questions, you come back and we can discuss it.
Thanks so much. Okay, thank you. So now back to TF-IDF. Okay, so anybody wants to like explain does anybody understand the concept of TF-IDF? Or anybody wants to give it a shot? Okay. Okay. TF-IDF uses this idea that okay. This is let's say we have one, two, three, four, five, six, seven. We have 7 documents, right? We have 7 different documents. So now say that okay, if a word occurs like so many times in a particular document, that means it is important. So that means it is very important in that particular document. Yes, okay. In all these 7 documents now, if that single word again is now in all of these words, in all of these documents, and it's the frequency is also high, then that means the relevance of that word is very minimal. Okay, let's take a word like D. THED. Okay. Let's say in a single file now, definitely in a single document, you can have it up to like I don't know, probably out of 500 words, you might probably have it up to like maybe 50 or more. But it's a very common word, which means that it is important. But that is telling you that okay, it is probably important in this particular one. But so it now checks out all these documents. I said, okay, in one it is 50, another one it is 40, another one it is like it is also high. So that means that is just like a general word. Probably all these EPA words and all these words like so that means that they don't really contribute much to the overall document. But if it only appears if it appears much in a singular document and it doesn't appear like and doesn't really appear in other documents like that, that means that okay, it is a very important word. As much as it is localized in a document, it's that means it is those words is those is preserving a particular context within the document, which is not like present in all other documents in the documents within that. Did, did I make any sense at all? Does that make any sense?
Not really.
Okay, okay. Look at this one. This NL look at this word NL, look at this NLP. Okay, let's say this, so this is just 2 here, but let's just say it is 3 in this particular image. There are three words that talk about NLP out of 10 words in this here. So 3/10, that is still a pretty that's 30% frequency in a single document. So In other document, in this document, it is not present in this document. So this particular one is what we call term frequency, TF. Hmm? Then we now have inverse document frequency. This is term frequency and inverse document frequency, which is now that okay. If this same NLP now is present in all these words. So this that the more present it is in all the other documents, the lesser its relevance. Because it is that means that it's just like it is common to everybody. So it is not unique in any way. It doesn't that means it is not contributing much to all these documents. So that's just like it's just that the more the words, the lesser the significance. This one is saying the more that is this one is saying the more the words, the more the significance. This one is telling us that the more the word in this particular context, the lesser the significance. Does that make any sense? Or should I come again?
It makes sense. It's okay. Yeah.
So yeah, like it is those this is like there are two this TF-IDF, it combines these two techniques together, mm, to give us a TF-IDF score. This first one is time frequency, and this one is inverse document frequency. This time frequency is for each document within a let's say a database. In a database, we can have, let's say we have, yeah, in our database, for example, now, we have 7 documents in our database, right? So TF this TF time frequency will check each document and see, okay, check each word and see that, okay, what is this? So it's that this what it does is that if a word is much, okay, let's watch this 8 minutes video. Okay, let me play video. Can, can we hear it?
No, we can't hear the
No,
sound.
Okay, you can hear? Okay. Okay.
Yes, there's no audio.
Okay. I'm coming. I'm coming.
Yamife, I think you're gonna have to click on audio setting and then maybe enable the button that says here incoming calls ringtone. I'm not sure, but you can try that.
At the more, right?
Can you say your audio button?
Word-like algorithm
Now
where
we
you
can hear
compute a
you.
vectorized feature for
Okay.
each document in
Okay,
your
let me start
corpus
as well.
based on the words found there.
Okay.
Price feature. Hi everyone, this is YML and today we are
Should I
going to
increase
talk
should I speed it up or
about term frequency, inverse document frequency, or TF-IDF for short. This is a quite popular algorithm in
hi
natural
everyone, should I speed it up or should we go at this pace?
Let's go at this pace. I think it's not too long. It's
Okay.
almost 9 minutes. So let's.
Let me know if you want me to on the subtitles and if you can hear it. Should I on the subtitle?
language processing that
No, I think it's okay with
yes.
me.
Sorry?
I think it's okay.
I should leave it.
Let's just leave
Okay.
it like this.
for extracting features from text. TF-IDF is a bag-of-word-like algorithm where you compute a vectorized feature for each document in your corpus based on the words found there. Also, this algorithm is called bag-like because the order of the words in a sentence does not matter, which, if you ask me, is quite important because the order makes contain valuable syntactic and semantic information. So, for example, if you have the following three documents, the TF-IDF algorithm will compute a vector for each of the three, and each document will contain a numerical value for each word found in the corpus, like cat, house, dogs, friends, and so on. And the first part in the TF algorithm is to compute the term frequency of each word found in the document. And you can do that using the following formula. So we have the TF, the term frequency of your term in the document. And on top you have the frequency of the term in the document divided by the sum of all the words found in that document. And if we apply this formula, we obtain the following values for the term frequency of our first document. So, for instance, for the word D, it is found twice in our document, once here and once here. So the value of the numerator is equal to 2. And we have a total of 1, 2, 3, 4, 5, 6. 6 words in the document, so the value of our denominator is equal to 6. And if we divide these two values, we obtain 0.333. And let's compute this value once more, for instance, for the word cats. Cats appears only once in our document, so the value of the numerator is equal to 1. And again, the value of our denominator is equal to 6. And when we divide these two values, we obtain 0.66. And we do this algorithm for all the words in the document, like are, in, and house for the first document. But we also compute the values for the words that are found in other documents, like dogs, outside, and so on. But do these words, we assign the value 0 over here, because these words are not found in our document, and if you look at the formula, then the numerator would be equal to 0, so automatically this value will be also equal to 0. And we can apply the same formula to obtain the vector for the second document and again for the third document. So after we compute the term frequency, we obtain three vectors, one for each document, which represents how often a word in our corpus is found inside that document divided by the total numbers of words inside that document. The second part of the TF-IDF is the inverse document frequency. And here we look globally at how often a word is found in the document. So what we have here in IDF, it takes as input the term T, capital D, and this D is different from the one used in the term frequency formula. Here D represents all the documents in our corpus and represents the total number of documents. And here on the denominator, we compute a set of documents, so D in all our documents, that have the property that they contain the term T. And finally, we compute here the cardinal of that set. So basically what happens here in the denominator is that we compute the total number of documents that contain the term T. And finally, we apply the logarithm here. I believe that this is applied because if the number of documents is very big, then the IDF term also becomes very big, and the logarithm is applied in order to obtain a more reasonable value over here. And now let's see how the IDF computes the value for the words using the documents from our previous example. So these are basically the values computed by the IDF for the first document. So for the here, this is a very interesting case because the appears twice here. but because the appears also in the second document and also in the third document, we basically have here the logarithm of 3, so the total number of documents, over how often or in how many documents this word appears. And we saw that it appears in 3 documents. So we have logarithm of 3 over 3, which is equal to logarithm of 1, which is equal to 0. And also, let's try to compute it for the word cats. So we have here logarithm of 3 over, and the word cats appear once here and once in the last document. So we have logarithm of 3 over 2, which is approximately equal to 0.176. And we can apply the IDF formula to compute the IDF value for the rest of the word found inside the first document, and also the vectors for the second document and also for the third document. And now let's try to get a better understanding of what the IDF part does in our algorithm. So basically it tries to put more emphasis on the words that are less frequent in our documents. So basically, let's look at the word here, the. So it appears in all the 3 documents, and as a result, it gets the minimum value possible, which is a value of 0. On the other side, we have the words outside and friends, which gets like a very high value in our IDF vectors of 0.477. And they get this value because they appear only once in our documents. Outside appears only once in the second document, and also friends appears only once in the third document. And now we can compute the TF-IDF vectors by taking the turn frequency vectors and multiplying them with the IDF vectors. And this way of computing the document feature is very powerful because what you are looking for are words that have both a high frequency inside the document and that are not found that often in other documents. And I hope that you can guess by now that this is a very powerful thing in things like information extraction, because it allows you to search for more relevant documents given some keywords or queries. As always, I hope that you found this explanation of TF-IDF useful, and if you did, please leave a like to this video, and until next time, I hope that you have a great time. So yeah, see you.
Okay. Oh, sorry, I was muted. Hello, everyone. Are we still there?
Yes, we are.
Okay. So now, do we understand the concept of this TF-IDF now? Do we understand the concept of the TF-IDF?
Yes.
Okay. Okay. Can somebody now, based on what you just watched, can somebody just like just explain it to us what you understand by what's the FIDF does and how it does it? Does anybody wants to
For
volunteer?
term frequency, a
Mm-hmm.
sing- it takes the occurrence of the word and divide it by the total package of the data, the data set. Then
Just
for
okay.
For inverse document, it picks in each, if the dataset contain like three different sentences, it picks the appearance of the word in each of the sentences and divide it by, it pick the logarithm, that's the logarithm of the word of the word that occurs in each of the sentences, sorry, in each of the sentences, and divide it by the number of sentence. That's if you have like five sentences, it picks the appearance of the word in each of them and divide it by the number of the sentence. That's the logarithm of all of it, the definition, the division rather. And then at the end, we use the term frequency to multiply with the IDF. Sorry.
Yeah. No problem. I think that was a nice try. Nice. I think that's actually nice. Ghanaians, you can
No,
proceed.
I was going to
Okay,
say that,
so
yeah,
okay.
Precious, before you go, you're almost correct. But it's the other way around for the inverse document frequency. It's the no like n over the number of occurrence. Just
Okay.
yeah, so it's like it's the number of document logarithm of the number of document divided by the number of time each of the word, the term appear in each of the document. If you remember, for D appeared in the three documents, so it was three,
3/3.
the three documents divided by three, which is the number of
Okay.
times that D occurred in each of the documents. And then we did the logarithm of that, so that became 0.
Okay.
Does Ghanaians also tell us about?
No, I just want to like correct the same thing Mr. Jumadi just said.
Okay. Okay. I thought you also wanted to talk, so I wanted to, so I'll be able to like talk about it together.
Oh,
Regardless,
do you
thank you
want me
so
to,
much.
to summarize as well?
Okay, sure.
Okay, let me give it a try. So the time frequency, based on my own understanding, what it does is like for every word in a document, it checks the number of occurrence per sentence. Should I say per sentence? So for example, the cat is blue, so it checks the cat is blue and it is so let me just say it checks the number of occurrence of a particular word over the total number of times, total number of words in that sentence. So, and then the inverse document, what it does is it checks, this first takes the total number of documents, then it divides it by the total number of time a particular word appears in a document. Then we take the logarithm of that for us to get the the IDF.
All right, thank you so much for that. So it is the TF is not like sentence, it is like it checks the number of times a word appear in a document. That's it. So the document now can be a sentence, but not like it checks the number of words in the sentence. So but it checks the number of words in a document. So the document can now be a sentence or not. So so the document is now like based on the context. But the context in our example now, the documents in our context now, the documents in the context of the video that we just watched is what is just a sentence. Do you get that, Ghanaians? Hope you don't really get that mixed up.
Yes, I get it.
Mhm. All right, thank you very much. So okay. So I guess we all understand the concept of TF-IDF right now. Do we understand the concept of TF-IDF right now? Can we proceed? Okay. So what embedding? So does anybody wants to, tell us what they understand by word embedding? Does anybody wants to give it a shot? No wrong answer. There's no wrong answer.
Yes, the O3 during at Microsoft that team. I told them looking at this hacker. We can think of something more we'll discuss.
Honestly, I don't. Okay. Okay. Does anybody wants to talk about it? Okay. I guess I'll take it. So, okay. Word embedding now. There's something word embedding. I'll try to explain it, and if I'll try to explain it in words, but yeah, let me try to explain it in words, and then probably we'll have to like go into. I can check the lab. Okay, so what embedding does is that when you train, okay, the first thing you train for, if you have a or a if you have a couple of words, let's say you have a sentence or you have a document that has different sentences and different words. The first thing you do is that you train your word embedding. So the thing is you make it understand, you give it the context. First of all, feed it your um you have first of all feed it your old data sets, your old document, and afterwards so you feed it and then you train it on your document. So it understands what it understands your each words and the surrounding words. Okay. I don't know if I'm making any sense. So let's say we have apple, orange, banana, car, and post. If you put everything in, okay. Oh God. If you put everything into it, the first thing, okay, let me take it step by step. Word embedding. You put your sentence, first of all, you train your word embedding model. So after training your word embedding model, and then you want to like get like how your model trains it. The thing is, it takes into context, not it, though we are everything still relies on this bag of words. But what it does is that it's how do I say it? It doesn't just take it takes into context. It takes into context the words before and the words after. It takes into context the surrounding words. The words that are surrounding a particular word, so that it will be able to say that okay, let's that way it will be able to tell us okay, can someone give me a word that can mean two different things at the same time, depending on the context? Maybe an app and
A word that can do what?
and someone does
A word that can do what, please?
that can mean two different things depending on the context. Let me and I why is nothing coming to my head right now?
Joy.
Oh,
Joy. Okay. You can say joy. Okay, joy as
As a name,
joy as
as a name, and joy as like feeling.
yeah, okay. Yeah. So thank you so much for that. So listen, one thing what the embedding does is that it will be able to like take if you have been if looking at all this TF-IDF and this ngram and this bag of words, it doesn't take even as much as it takes into context previous ones, but there's no much relationship. It doesn't like there's a little bit of context that it understands. So what the embedding does is that it's able to like to some extent understand the word based on the surrounding words. So what the embedding will be able to tell us that okay, this particular joy in this word, let's say joy is feeling so. Can we say joy is feeling so? You cannot. I'm looking for joy is feeling so joyful. No. Any sentence? Can anybody come up with a sentence that makes sense? But do you get? You can. So it will be able to tell us that joy at okay. Let's say this joy at the beginning of the word, at the beginning of the sentence, is not a feeling. This joy is the name of a particular person because it is at that point it is serving as a noun, and then at another point it is serving as a, what would that be? Is it preposition? I don't know. It is a feeling, and then at another place it is a name of word. So that's basically what embedding. That's basically what it does. But before it goes into it, what embedding does, it does something. It has a like a context window. So I think all to Vec has a context window of like up to like 300. So the thing is, that's why I'm saying that you if it has like a 300 context window, which is it can define 300 300. The bank is at the bank. Okay, the bank is at the bank of the river.
Pillowcase.
Sorry? Shalom, am I saying something?
No.
Oh. So okay, look at the bank is at the bank. The bank is located at the bank of the river. If it's just the normal bag of food, it's just that it doesn't see the difference between this bank where we save money and this bank which is which is uh, which is by the river. So it doesn't see that, it doesn't understand that particular context. So what embedding takes that into consideration, and it maps them into an embed, we call it an embedding space, like an n dimension, so it maps it into a dimension. So it gives it not just when we did, remember when we did Google account assignment. What was wrong? I might not be able to access this, so because I was signed out on a different tab. I didn't sign. Okay, regardless, okay. I might not be able to run this because I think something is wrong. I need to fix that. But let's come back here. Okay, look at this. When we're doing one-hot encoding, you see that this is just students here just ask like this number, right? One thing, instead of just this simple, word embedding, it gives it a unique set of numbers. It gives it a unique set of numbers, which are not just 0 and 1, but they are mapped out in a vector space. So it was okay. So I can tell you that okay, these are fruits now. They can be mapped. They will be this apple, banana, orange. They will be mapped together. They will be mapped close together because they are all what? Fruits. These vehicles, they will be mapped close together because they are vehicles. Does that make any sense? So instead of that 0, 1, 1, 0 that we're having in instead of that we're having in what's it called, in one-hot encoding, it gives it unique numbers, and those numbers represent the position of those words in the embedding space. Does that make any sense at all? Or I am speaking Gibberish?
No, not really. I think I'm understanding what you just explained.
Let me check what to let me just do. Let me check. Let's probably should we watch should do I need to like play a video on what to make, or oh, this is 16 minutes. Okay. Do I need to like play a video, or your voice clear enough? I need responses, please.
I think we just need to go and read more about it, right? Based on your explanation.
Anybody else has any other? Is anybody else has any other things? What do we also suggest? It's only Ghana that is speaking.
I think the
Yes,
same
please.
thing.
You could share the link with us, then we look it up later ourselves.
Kindly send it to us, sir.
Okay. The thing is, I've not watched these videos. I've not watched these videos, but probably I can. Okay, I can just copy. I think this has a lot of visuals. Um, so I think, and okay, also do this. This also has a bit of visuals. So, um, yeah. So let me drop those two in the chat. So that's what embedding does. But once the only the so you can see that these things keeps improving. TF-IDF doesn't take into consideration the surrounding words. It just talks about word frequency, which to some extent is effective, when we are processing text. But what embedding like takes into consideration the surrounding words, and it also maps it in different embedding space in different embedding spaces to understand, so similar words are grouped together. So, and these words that are different from each other, like they are different, they are maps in different embedding spaces. So that's basically how what word embedding does. But this word embedding, it has a shortcoming, which is that the word embedding space is small. So I think that a word it has word to vector. I think that one has only up to like 300. And imagine there are a lot of words and there are a lot of context. So though it reduces this, what do we call it now? It reduces this, if we are using just bag of words and we are using n-gram, those ones is just like it's just by just a single word. But this one doesn't just like, so this particular method can increase computational capacity if you are working with a lot of text. So which means you'll be processing a lot of text like every time. So which can take time and which can cause a lot of computation by it. So, but what this does is that it shrinks it into a particular context, which is 300, and then it maps them into that particular window. So each word is able to like have specific unique numbers that represent it in that embedding space. So due to the limit, but the thing is due to the limitation of word embedding, that is where transformers now come. So the thing is, what transformer does is that transformer has a higher context. It has a very high context length. It has large language models have very large context length, and they are able to use they are not just what embedding can only use to local surrounding words. Transformer models are able to use words even from the beginning of a document, even not like um they have a large context window. So as for the time we have also like when you can process a context length of 120,000. But the one 120,000, imagine that over just using maybe like the next 5 or the next 10, like 5 or 10 neighboring words. So transformer embeddings, like they are much more powerful because of there's this because of the relationship between them, all this there's this transformer mechanism, attention mechanism, which they introduce, which is that every word, all the words in a document, all the words in the document now can interact with each other almost all the words in a document can interact with each other. So even if a word is at the beginning of a document and another word is at the end of the document, the attention mechanism can, find out if there's a relationship between the word at the end and the word at the beginning of a document. So that is what makes transformer mechanism very powerful. So it is this, so that's the best method. That's the state of the art. That's what ChatGPT, Gemini, and that's what they utilize. And also at that point where we have also the query part. Um, yeah. So the Korea this I don't know if anybody knows about Korea, but does anybody know about Korea? Does anybody know about Korea? Yes or no?
About what?
This organization, or is it Korea or Korea? Does anybody know about them? So okay, if we don't, sorry.
Yes.
Go ahead.
Okay. Okay. Yeah. So the thing is, this Korea organization, they are an AI they are an AI organization, and they release open source large language models. So there's something called closed source and open source. Ah, okay, something like ChatGPT now is a closed source model because you cannot use it. You can actually interact with it, but the real mechanism that is behind ChatGPT, the recent ChatGPT, the mechanisms is also called the weight and the architecture is not made public. So they are closed source language model. But there's a platform we call Hugging Face. So most language models that you can easily interact with and use to build models anyhow we want. Most of them are always released on Hugging Face. So there are different organizations that release language models. There's this Korea, there is a Meta, which the parent organization of Facebook. Those people, they release different versions of Llama. There's also Anthropic. There's an organization called Anthropic. Their models are majorly called Mixtra and Mistra. Which other ones? Google also they own Gemini. Is there any other organization that we know about? I think those are the organizations that I know of at the moment that release open source language model. So we can easily in these language models now we can easily interact with it and use it to perform embedding. I don't know what is wrong with my stuff. So please let us interact with this. So they have a larger they have what large language models do is that they have a larger context and they are able to do much more. And they are able to, yeah, thank you, DeepSeek as well. DeepSeek, DeepSeek, yeah, which open source language model is Microsoft using? I'm not sure if I know any language model that's any open source. Yeah, Copilot. Yeah, I think that's true. Yeah, that's true. Yeah. So thank you for that. Thank you for that. So I will need just to interact with this. So that's basically that's the overview. It is already getting too technical and too deep for this level. So I would just advise us to interact with this notebook, interact with it. Let me know whatever challenge you're facing. You're able to run it, understand, try different things out. Ask why is this, why is that, and you will see and try to read the code. If there's a code, if there's a particular aspect of the code that you don't understand, you can share it on, you can snap it and send it to to the group. Exactly. Hello.
Yes, that's well understood. Thank you so much.
Yeah. So I'm trying. I don't want. The attention mechanism is a very. It's not so. It's not that stiff, but trying to go into. It's just about. It's just. It's a bit dicey to explain to you guys, but it's just that, as I just said, all the words learn all the words in a particular document or in a particular document, they learn the interrelationship between each other. Hmm? The words before, the words after. So depending on the language model now, if it is ChatGPT. Okay, if you're okay, wait, if it is ChatGPT, okay, first of all, let me let me just say that they learn the interrelationship between each other, and then based on the interrelationship between each other, they're able to like fix all those words in different uh in different context window. So I think the GPT-2, I think it has context window. It has a context size of also like, I think, was it not 50, embedding size of also like 50,000 embedding size. That's an embedding size of 50,000. 50,257, if I'm not wrong. So they have a larger capacity, and that is GPT-2. And recent language model have been having like larger and larger and larger. So they're able to understand much more context and able to do better than all these rule-based and other methods. So let's just try it out, and yeah. If you want to understand much more and on a deeper level, this embedding stuff, then you have to like take your learning even beyond machine learning. You have to like delve into deep learning and transformer mechanisms. So, but for now, I think that would be a long shot. Let's take it step at a time. So, any question? Any addition, subtraction, any contribution? Are we sure we understood everything I have said like this? No one is speaking. Am I the only one on the call? Please please just unmute your mic and say something. Okay, Ghanaians, who has been like the most active? Please say something.
Yes, I'm here. Sorry. I didn't get the last question.
Yeah. Yeah, it's not a question. I was just asking that. Okay, does anybody has any contribution, suggestion, addition,
None
subtraction?
from me. No, nothing from me.
Okay.
No, it's a question.
Anybody else? Sorry?
None from you too.
Okay. Cecilia, Precious, Nancy. Who else am I seeing?
Not
It's
from me
my
too.
okay. So can we call it? So I guess, is this a nice place to like round it up?
Yes. Thank you so much for your
Yeah.
time.
Yes.
Yeah. So
Yes, it is.
yeah, sorry for taking so much of our time.
Yes, thank you.
So
Thank you so
please
much for
Thank you so
run
much.
through the yeah. Thank you for joining. So run through the material. If you face any challenge, let's bring it to our attention. Somebody else might be in the channel to answer. And as soon as I see the question, I will I will definitely try to answer. So yeah, thanks so much. And tomorrow we'll go into machine learning proper. And yeah, thanks so much for sticking around. And it's been nice seeing you guys, having you guys around. Have a nice weekend. Have a wonderful
Thank you
night
so
rest.
much.
Thank you.
Yeah. I hope it was not a waste of our time too.
At
No, it
all,
was
at
not.
all, at
It's
all.
very helpful.
No, it was
Very
very helpful.
helpful. Thank you.
So please, if you have any challenge, please don't like let us know on time so that we'll know how to fix things and
I,
make
I
things
have a
work.
question. Maybe the assessment is not closing tonight, you know.
It isn't. It is not close.
I'm still working on it, but like they don't have our light. So I'm thinking like by midnight they'll bring it back.
Yeah. Oh, right now the deadline is tomorrow. Tomorrow, end of the day by
Oh,
tomorrow.
thank you.
Yeah.
Thank you, sir.
So yeah. But so just let us know. And if you are facing any challenge, let us know. And so we'll know however we can be of help and whatever we can. We are not here to make anybody feel. We don't want anybody to feel. We want everybody to do it. And when you present this project out there, I want you to be able to beat your chest that actually you did this. You are not doing it because AI Saturday says you guys should do it. You are doing it because you are building your skill. You are building it for yourself. And yeah. Don't worry, even when we get into the real life scenarios and you get to what your work is, there will always be challenges that you face, but you have to like dive in and attempt it, look for resources that can help and yeah. No, but no one is an island of knowledge. We keep learning every day. So please embrace challenges and these are challenges that will make you grow, not challenges that are just there to frustrate you. So thank you so much, everyone. Watch the videos about the embedding. And if you also want to understand, the the how the transformer model, how the attention mechanism. There's this channel, three blue, one brown. Three blue, one brown. So it does a lot of animations on transformer. So the name of the channel is three BIB or three blue, one brown. So you can check it on YouTube. Just check it just to see how the attention mechanism in the transformer model. So transform I said transformer mechanism. Attention mechanism, sorry. How attention mechanism works in transformer models. Sorry. So your attention mechanism. Sorry, scratch the transformer. So yeah. Thanks so much everyone once again for joining. Um really appreciate you and have a wonderful weekend. We'll send mail regarding tomorrow's material or the week's material tomorrow. So, anyone has any word before we'll call it a day? I will call it a week.
Last word. Thank you, sir.
Thank you too. All right, we can drop off. Bye bye.
Sorry, do we have to stay on this call?
No. Like that, we are done.